Say a massive, fast-moving visitor to our solar system may have been a probe sent by an advanced alien civilization. Astronomers were excited to discover the interstellar object last year. It was named Oumuamua.
Oumuamua first captured the world's attention when it zipped through our solar system in 2017, sparking endless debates about its mysterious origins. Now, after years of silence, it has been spotted again, but this time, it is not alone. This object is simply a piece of another solar system that was expelled and has been traveling through interstellar space for hundreds of millions of years, billions of years, perhaps. We don't know. Let's take a closer look at Oumuamua's strange journey and the theories that have followed. What's truly going on out there? Let's uncover the details behind the enigmatic return of this cosmic visitor and what it could mean for the future of space exploration, and what Elon Musk has to say about it. The universe, as we know it, will eventually dissipate into a fine mist of cold nothingness. Oumuamua has once again captured the attention of scientists. Before we dive into what's going on with this mysterious object, let's first take a step back and explore what comets really are and how this interstellar visitor came to be such a source of fascination. Is it a comet? What are comets anyway? What makes Oumuamua so unique, and why is it sparking such curiosity? Let's take a closer look at this odd traveler from beyond our solar system and uncover the mysteries surrounding it before we explore the latest surprising twist in its journey. Comets have fascinated humans for centuries. They have been seen as omens, signs in the sky, and even as visitors from distant parts of the universe. They appear unexpectedly, streaking across the sky with bright tails, catching our attention and sparking curiosity. But what exactly are comets, and why do they behave the way they do? A comet is a small icy body that orbits the sun. It is like a dirty snowball, made up of rock, dust, and frozen gases. When a comet gets close to the sun, the heat causes the ice to vaporize, creating a glowing coma, a fuzzy cloud of gas and dust around the nucleus, and often a long, shining tail that stretches millions of miles into space. To understand this a little better, think of a comet as a cosmic dirty snowball. Imagine a ball made of ice, dust, and rock. When it's far away from the sun, it remains frozen and solid. However, as it gets closer, the warmth of the sun causes it to sweat, releasing gas and dust into space. This is what gives comets their signature tail, which always points away from the sun due to the solar wind pushing the particles outward. Comets are ancient objects, originating from the farthest reaches of our solar system. There are two main areas where comets come from, the Kuiper belt and the Oort cloud. These regions lie far beyond the orbit of Neptune, where the sun's gravitational pull is weak. The Kuiper belt is a region of space that extends just beyond Neptune, filled with icy bodies. Some comets originate from here, and they tend to have shorter orbits, meaning they pass by the sun more frequently. The Oort cloud, much farther out, is a giant sphere of icy objects surrounding our solar system. It remains a mystery, as scientists cannot see it directly due to its immense distance. However, they believe this is where many long-period comets come from, comets that take hundreds or even thousands of years to complete an orbit around the sun. There are two main types of comets based on how long their orbits are. Short-period comets have orbits that take less than 200 years to complete. They originate from the Kuiper belt and visit the inner solar system more frequently. An example of this type is Halley's Comet, one of the most famous comets, which has a short-period orbit and visits the inner solar system roughly once every 76 years. Long-period comets, on the other hand, have orbits that take over 200 years to complete. They come from the Oort cloud and take much longer to return. Comet Hale-Bopp, which was visible in 1997, is an example of a long-period comet. Its orbit is thought to take over 2,000 years. The main difference between these two types is how often they pass by the Earth, and the Sun. Short-period comets return more frequently, making them more familiar to us, whereas long-period comets are rarer and originate from farther out in the solar system. A comet is made up of several different parts, each essential to its behavior. The nucleus is the solid core of the comet, composed of rock, metal, and frozen gases. It is usually only a few kilometers wide. The nucleus remains unchanged even when the comet gets close to the sun. This is the dirty snowball we discussed earlier. As the comet approaches the sun, the ice in the nucleus begins to vaporize, creating a glowing cloud of gas and dust around it. This cloud is called the coma, resembling a comet's halo, and can stretch for thousands of miles. The tail is one of the most iconic features of a comet. It forms when the solar wind pushes the comet's dust and gas away, always pointing in the opposite direction of the sun, regardless of the comet's movement. You might wonder, why do comets have tails, and why do they always point away from the sun? The answer lies in the sun's solar wind. As the sun releases charged particles into space, they interact with the gases and dust from the comet, pushing them outward. This causes the long, shining tail to form. The solar wind forces the tail to always face away from the sun, no matter where the comet is in its orbit. Interestingly, the tail does not always form when the comet is far from the sun. As the comet gets closer, the sun's heat causes more of the ice in the nucleus to vaporize, releasing more dust and gas. The tail grows larger and brighter. When the comet moves away from the sun again, the tail shrinks and fades. Comets are like time capsules from the early solar system. They are composed of materials that have remained largely unchanged since the solar system formed about 4.5 billion years ago. Studying comets helps scientists learn more about the conditions that existed in the early solar system. That was precisely what we hoped to do with Oumuamua, until recently. Oumuamua, the first interstellar visitor, made history in 2017 when astronomers detected something unusual passing through our solar system. It wasn't an asteroid from our solar system. Initially, scientists believed it to be a comet, but it didn't behave like any comet we had encountered before. It lacked a visible coma or tail, leaving experts puzzled. Could it be something else entirely? Oumuamua's bizarre characteristics led to countless theories, ranging from natural space debris to even the possibility of an artificial origin. What exactly is this mysterious traveler, and why does it continue to capture our curiosity? It was as close to a comet as it gets, at least, that's what the data suggested. Yet, it was something entirely new, something never seen before. A small, cigar-shaped object was passing through our solar system at a speed that suggested it wasn't from around here. This object would go on to be known as Oumuamua, the first confirmed interstellar object to visit our solar system. The story of Oumuamua begins on October 19, 2017. That day, a telescope in Hawaii called the Pan-STARRS 1, led by astronomer Robert Warwick, detected the strange object. At first, it appeared to be just another asteroid, but soon, astronomers realized something was off. The object wasn't behaving like an asteroid simply passing through the solar system. It was moving far too quickly. In fact, Oumuamua was traveling at a speed of just under 200,000 miles per hour relative to the Sun, far too fast to be gravitationally bound to our solar system. That meant it wasn't from around here at all, it was coming from somewhere else. This discovery sparked immediate excitement in the scientific community. The object wasn't just another part of our solar system, it was an interstellar visitor, traveling from another star system beyond the reaches of our own Sun. Robert and his team, along with astronomers worldwide, quickly realized this was something special. It was moving too fast to be held by the Sun's gravity, meaning it would pass through and continue on its way out of the solar system. Oumuamua would never return. But take this with a grain of salt, the name Oumuamua comes from the Hawaiian language, meaning a messenger from afar, or, more literally, a distant scout. This name was chosen because the object was not from our solar system, and it was the first interstellar object ever detected passing through our cosmic neighborhood. The name held another significance: the object was moving fast, coming from a distant part of the universe, almost as if it were carrying a message from far away. Astronomers worldwide took this name to heart, as it was a reminder that the universe was far more mysterious than we had once thought, with objects arriving from beyond our solar system. When astronomers began studying Oumuamua in more detail, they discovered that it wasn't a typical comet. In fact, it wasn't even round. The object had an elongated, cigar-like shape. This led to even more questions. It wasn't just its speed that was strange, it was its appearance and behavior. Oumuamua was observed tumbling through space, rotating about once every 7 hours and 20 minutes. This behavior suggested it was not a smooth, featureless object but rather one with an odd, irregular shape. Some astronomers described it as resembling a giant space cigar, while others thought it looked more like a pancake or a flat, elongated object. The exact shape of Oumuamua is still debated, but its strange tumbling motion indicated it had a very unusual form. One of the most intriguing aspects of Oumuamua was its changing brightness. As the object passed through our solar system, astronomers noticed that its brightness fluctuated regularly, almost as if it was spinning. This wasn't unusual for an asteroid, but the extent to which Oumuamua's brightness changed was more extreme than expected. The object seemed to get brighter and dimmer as it tumbled, suggesting it might not be a typical rock or asteroid. Initially, the cause of this fluctuation was unclear. Was it because the object was made of some reflective material, or was it due to outgassing, a process often seen in comets where gases and dust are released as the object is heated by the sun? More on this later, as we now know why. As astronomers gathered more data, they began to propose theories about what Oumuamua was made of. The object's reddish hue suggested it was composed of metal-rich material, similar to some asteroids in our solar system. However, its tumbling motion, unusual speed, and unexplained brightness changes raised doubts that it was a typical asteroid. One theory proposed that Oumuamua could be a fragment of a much larger object, broken apart during a collision in another star system. This could explain its peculiar shape and high speed. Another theory suggested Oumuamua was a comet. Comets often exhibit irregular shapes and fluctuating brightness due to their outgassing behavior when they pass close to the sun. However, unlike comets, Oumuamua didn't display a visible tail, and no clear signs of outgassing were observed. This made it seem unlikely that it was a comet in the traditional sense. One of the most important pieces of information about Oumuamua was its trajectory. As astronomers tracked its path, they saw that it came from the direction of the Lyra constellation and was on a course that would take it out of our solar system at a sharp angle. The object was moving so fast that it couldn't be captured by the sun's gravity. Instead, it was just passing through, like a cosmic visitor traveling through a neighborhood before continuing on its journey. Initially, astronomers thought Oumuamua had come from a nearby star system, but later calculations revealed it had been traveling for an incredibly long time before reaching us. This meant the object came from a much more distant part of the galaxy, possibly even from another region of the Milky Way altogether. By studying its trajectory and speed, astronomers confirmed that Oumuamua was indeed an interstellar object, unlike anything we had seen before. Its speed and unusual path made it clear that it wasn't part of our solar system and was simply passing through on its journey across the galaxy. Oumuamua passed closest to the Sun on September 9, 2017, and moved quickly through the inner solar system. By January 2018, it had already passed beyond Jupiter's orbit and was heading out of our solar system. Because it was moving so fast, it wasn't going to stay around for long. In fact, by the time astronomers had gathered enough data to study it in detail, it was already too far away to observe directly with telescopes. They believed that as Oumuamua moved farther from the Sun and Earth, it faded from view, and the opportunity to study it up close was lost. They also believed it was unlikely we would ever be able to observe the object again. But they were wrong. What was actually going on? In 2017, Oumuamua caused a massive stir in the scientific community when it was first spotted, but that was just the beginning. After it passed by, the object disappeared from view, heading beyond Jupiter's orbit and eventually vanishing from our telescopes. For years, scientists thought Oumuamua had gone, never to be seen again. But recently, Oumuamua was suddenly spotted again, this time, not alone. What's happening? There was some speculation in the beginning that Oumuamua might not be a natural object at all. Some astronomers, like Avi Loeb from Harvard University, raised the possibility that it could be an artificial object, possibly a probe sent by an alien civilization. Avi's theory gained a lot of attention, though it remains controversial. But it seems Avi was right on the money all this time. Astronomers and scientists had written off Oumuamua after its 2017 flyby, thinking it would never return. After all, its speed and trajectory suggested that it was on a one-way path out of our solar system, never to come back. Oumuamua had been hurtling through space at almost 200,000 miles per hour, too fast for the sun's gravity to capture it. Its trajectory was so sharply angled that it seemed impossible for it to come back into view, and no one had expected to see it again. But something unexpected happened. Oumuamua was spotted once more. However, this time, the object wasn't the lone, solitary interstellar wanderer that had passed through our solar system a few years earlier. There was something else accompanying it, something much smaller, orbiting closely alongside the giant elongated shape. This discovery sent ripples of shock and intrigue through the scientific community. Oumuamua was now accompanied by two mysterious smaller objects that seemed to be closely following its every move. It was as though Oumuamua had somehow acquired companions. One of the most puzzling aspects of this reappearance was the object's trajectory. As the new data came in, it became clear that Oumuamua's path had drastically changed. Prior to its disappearance in 2017, scientists had predicted that the object would continue on its current trajectory, heading out of the solar system with a wide arc that would take it far from the sun. However, astronomers realized that the object's trajectory had bent in a way that wasn't expected. It seemed to have veered toward the sun at some point in its journey, which didn't make sense. No one could say exactly how much Oumuamua had changed its trajectory or what had caused the shift. Some speculated that it had passed too close to the sun, possibly causing it to alter course due to gravitational forces. But why did it fly so close to the sun? And how did it gain the speed necessary to make such a drastic change in direction? This left scientists scratching their heads. The most plausible explanation initially seemed to be that the object had gone through a series of gravitational slingshots, similar to the way NASA's Voyager spacecraft had used the gravity of planets to adjust its path. This method of using gravity to alter speed and trajectory was well understood. But the fact that Oumuamua had flown so close to the Sun without being detected by major observatories was troubling. It raised questions that no one had been able to answer. One of the most perplexing aspects of the entire mystery was how Oumuamua managed to evade detection for so long. Despite the fact that the Sun is a massive gravitational force and the object passed so close to it, the usual methods of detection had failed. NASA's Stereo-A spacecraft, which is positioned permanently to monitor the Sun, had not picked up Oumuamua during its close pass. This seemed impossible. Stereo-A is tasked with keeping an eye on the Sun and its surrounding space, and its instruments are always scanning for objects within the Sun's gravitational influence. Yet, somehow, Oumuamua had managed to slip past it undetected. Some scientists speculated that Oumuamua could have entered the Sun's orbit in a way that was so unusual that it didn't trigger any alarms. Its odd, irregular shape and its high velocity could have played a role in making it more difficult to detect. Perhaps it was simply too small, too fast, or too distant at the time it passed close to the Sun for Stereo-A to register it. This led to further speculation. Could there be something about Oumuamua that we didn't understand? Was it behaving in a way that we hadn't anticipated? Or was it possible that we were simply looking in the wrong place at the wrong time? Adding to the intrigue of Oumuamua's reappearance was the discovery of smaller objects traveling alongside it. These companions were moving in perfect sync with Oumuamua, almost as if they were being pulled along by the larger object. The question that immediately arose was, what were these smaller objects? Some researchers began speculating that they could be a kind of probe or even a scout sent from another civilization. If Oumuamua was indeed a kind of interstellar ship or message, as some had suggested in the past, then the smaller objects could be companion craft. Their roles could be to monitor Oumuamua or even to prepare for future missions, possibly with an agenda that we could not yet understand. Avi Loeb had famously suggested that Oumuamua could be an artificial object sent by an alien civilization. His theory gained attention when he argued that the object's unusual characteristics, its elongated shape, its high speed, and its unexplained behavior, suggested that it wasn't just a natural object like an asteroid or a comet. Loeb proposed that Oumuamua might be a probe, a type of spaceship sent to explore our solar system. With the discovery of the smaller objects, we revisit Loeb's theory. If Oumuamua is indeed an alien probe, then perhaps the smaller objects were companion ships sent to monitor the larger one. Elon Musk believes this theory unveils everything. It perfectly encapsulates the changing brightness we couldn't describe and decipher 8 years ago. It is metal-rich because it is a ship, and it is clearly made of metal. It is traveling at speeds we have yet to reach, which means that this civilization is far ahead of us. And dodging Stereo-A? It can only be explained by having much more advanced technology than it. Elon stated the following: "This is bad. Either we're being watched, or something even stranger is going on. If these objects are probes, it means someone or something is actively observing our solar system. And if that's the case, we should probably start asking why." The return of Oumuamua and its companion objects raises more questions than answers. How did the trajectory change so drastically? Why was it not detected by NASA's Stereo-A spacecraft, which is designed to watch for objects passing close to the Sun? What is the nature of the smaller objects traveling alongside it? And could it be possible that Oumuamua was never just a random interstellar visitor but part of something larger? For now, the answers remain elusive. Scientists are continuing to study the new data, trying to piece together the puzzle of Oumuamua's mysterious journey. While it may never be fully understood, the discovery of this strange visitor, now accompanied by 2 more, has sparked renewed interest in the mysteries of our universe. What is certain is that Oumuamua has changed the way we look at the cosmos. Its return, along with its newfound companions, raises the possibility that we are just beginning to understand the true nature of the universe, and that we are not as alone as we once thought. What would it mean if Oumuamua is a spaceship? Let us know in the comments.